Hi everyone. So I'll be discussing in this video how Erasure coding ensures very high durability in distributed systems. So in this scenario where I want my data to be extremely high durable, so in the range of let's say 99.999% of durability. So how do you achieve this sort of durability where replicating the data across multiple data zones does not give you the suffice durability? So there we use erasure coding. So we'll explain how erasure coding ensures this durability. Now, this is an encoding technique where I have, let's suppose, a data D. I chunk it and make it into multiple fragments. So let's suppose C1, C2, C3, all those are chunked data. So this technique ensures that the data is chunked into multiple small fragmented data, and there will be redundant fragments also. What do you mean by that? So I'll explain this in a bit. Now, what is the goal of this erasure coding? So let's suppose I have two nodes where I have replicated my data. I'm not using erasure coding as of now, I've just replicated. But what if my data gets corrupted in this node also and in this node also, in node N1 and N2? There is some corrupted data here and my data gets corrupted in the second node also. Or let's say in the first node also, my data gets corrupted. Now there is no way to validate the data of D2, which is in the N2. And if this data, this node also gets corrupted, we don't have a way to generate the data back. So the goal is to reconstruct the data. Even some of the fragment data are lost or corrupted. So in the ideal scenario, what would I want? If let's suppose I have one data, if I can, this is my D1 data, if I can fragment it, fragment the same data in let's suppose C1 and C2, and I store it into this node N1 and I store the C2 in node N2, and in this scenario, for example, this gets corrupted, I can generate the data only by using C1. If my failover or this node gets crashed, I can generate the data using this C1. I hope this use case is clear. Now, as I said, this is used when you need extremely high durability. So for example, in the Amazon S3, similar techniques are used. There is a Redis gateway where we can, this similar technique are used, and Hadoop SDFS, here also erasure codings are used. Now, interesting use case, NASA also uses this encoding technique to communicate with their satellites. So now I'll explain what this technique is exactly about. Now, erasure coding has, there are some techniques which can be used as part of erasure encoding. First is Reed-Solomon technique, which I'll be explaining this in this video. And also this is the most widely used technique when you try to use erasure coding. Now in this we represent the scheme as n comma k, where k is the original data and n is the generated data, and n will always be greater than k. So for example, I have two data, and when I write 4,2, this means that my 2 data gets fragmented and 4 data gets generated. So let's suppose this is A and B. There are 2 letters, and the 4 letters with 4 fragmented data will be generated as F1, F2, F3 and F4. So this 4 data will be generated, and this is the original data. So here n will always be greater than k. So that means this 4 is as I said, 4 will be greater than 4 is greater than 2. So this means my fragmented data is always greater than my original data. Now, what exactly is erasure coding? Using Reed-Solomon technique. So here we use a formula where we have a G into D equals to C. Now G is a generator matrix, D is my original data, and C is my encoded fragments. Now I'll explain this with example. Now I am using here 4,2 scheme. So as I explained, this is my original data and 4 is my generated data. So for example, I have two data H and I. These two data I have to encode and keep it on different nodes. So first of all, how will I encode using Reed-Solomon technique in erasure coding? So the ASCII value of H is 72 and ASCII value of I is 105. I will use a generator matrix which is nothing but 1 0, 0 1, 1 1 and 1 2. So this is my generator matrix. So as per the formula, I will generate the fragmented data. So where I will use the generator matrix and multiply this by this with my original matrix. So first is I will multiply every row, every element of the row with each of my original data. So my first part of data, which is C1, gets generated as 72 into 1 plus 105 into 0, which gives me 72 as the result. Similarly, in the second fragmented data will be 72 into 0 plus 105 into 1. So this gets multiplied into this, which gives me 105. C3 is 72 into 1 plus 105 into 1, which is 1 and 1, and here I will get 177, and C4 will be generated as 72 into 1 plus 105 into 2, which will be 282. Now, so now what are my generated fragments, which is C1, C2, C3, C4, which is 72, 105, 177 and 282, and my original data was 72, 105. Now, while storing the data, what I will do, I will keep C1 and C3 in one node and C2 and C4 in another node. And let's say my node 1 crashed or failover happened or my data get corrupted. Now I only left with C2 and C4. This is the only data I am left with. Now my job is to generate the original data using C2 and C4. So as I know, my fragmented data or generated data was 105, which remained as it was part of N2, and I have C4, which is 282. These two data I have with me. But one observation is that I already have the knowledge of my generator matrix. So because generator matrix, it's a static matrix, it doesn't get changed with the data. So we know that when, let's suppose we get C2, we know that what generator matrix, what exact row has been multiplied. So here G first has been multiplied, which is 0 1, and G3 has been multiplied, which is 1 2. Now using these two information, can I write, let's suppose X was my original data, X and Y was my original data, X into 0 plus Y into 1, X into 0 plus Y into 1 equals to 105. Can I write this? Yes. Second is X into 1, X into 1 plus Y into 2, which will give me 282. So as you can see, this is a very simple equation, and from which I can generate my x and y values, which will come as 72 and 105. So hence we got the data even with the chunk of the data which was stored on the different nodes. So this similar technique, as I earlier explained, when there is a very high durability is needed. So one thing is that you can replicate the data across multiple data zones. But if you want more durability, along with that, you can apply this technique, which will ensure that even some data gets corrupted, you will get the original data. Now there is one question which is remaining, that how did I choose my generator matrix? Now, how will you choose your generator matrix? So first k rows. So first k rows, as you saw, it was 1, 0 and 0, 1, which are called identity matrix, which will give me exactly the same data. So from here you can see I got 72, and here from here I got 105. So this is the identity matrix. The next set of rows of generator matrix is basically linear dependent row. Linear dependent row, which is nothing but 1, 1, which gives me exactly the same row with multiplying with the single row. Here I got 72 and 105 with two different rows. Here I will get 72 and 105 by multiplying 1, 1. And third, it is linearly independent row, which is not exactly 1, 1, but it will be some random values. So here in this case 1, 2, and using which I got 282. You can read more on how to generate a matrix. There are multiple techniques which are used in generating this matrix also. This is one of the technique. So yeah, so that's all for this video, guys. That's all for this video. Thank you.